Once again, good afternoon, everyone. My name is Dick Kraut. I'm part of the organizing committee here. Before we begin this closing plenary, which is something that's new to the Ocean Sciences meeting, I have an announcement to make. Professor Nancy Marcus, who was the first female president of ASLO, who was also the dean of the graduate school at Florida State University until just recently, passed away on Monday during the conference. So if we could just take maybe 30 seconds to think about that and contemplate. All right, thank you. For our final plenary today, we have a short program for you. Paige Martin of the University of Michigan is going to provide a small interpretive dance for us. And then we'll have our speaker, Mike McPhaden, and then we'll close the meeting with a few announcements. So at this time, I would like to welcome Paige Martin to the stage.
Well, technically it's only of the ocean and the troposphere. It's quasi-geostrophic and it isn't even seasonal. But we as ocean modelers think this is all quite reasonable. A model maker needs a mix of math and ingenuity, and intuition's needed to remove some incongruities. But when your model runtime is so close to perpetuity, it gives you all the time you need so you can go and brew a tea. It gives you all the time you need so you can go and brew a tea. It gives you all the time you need so you can go and brew a tea. It gives you all the time you need so you can go and brew a tea. Stress PB conservation, beta plane approximation, AMOC and cell resolution, time stepping and sublimation, detrending and tapering, interactions nonlinear. I run a modern model of the ocean and the atmosphere. Detrending and tapering, interactions nonlinear. I run a modern model of the ocean and the atmosphere. They said that Fortran coding was an easy thing to generate, and when it's running well, this is a believable postulate. But coding errors come along and seriously aggravate, and server downtime sure something that every modeler comes to hate. But Python's so much cleaner and makes easier analysis. And ask an ceramic IO fast without paralysis until your job submits and you wait at the bottom of the queue. And then your code errors after 1 microsecond, maybe 2. And then your code errors after 1 microsecond, maybe 2. And then your code errors after 1 microsecond, maybe 2. And then your code errors after 1 microsecond, maybe 2. From barotropic, baroclinic, and RC interaction, from deformation radius and CFL criterion, from raspy waves to turbulence, vorticity, vertical shear, I run a modern model of the ocean and the atmosphere. From raspy waves to turbulence, vorticity, vertical shear, I run a modern model of the ocean and the atmosphere. Research using models too has numerous good qualities. For instance, I can work inside without risking my life at sea, or predict future oceanic circulation credibly, without the need to change the ocean, which could end up terribly. A PhD leaves lots of time for making friends and drinking beer, rewriting words to musicals to sing to scientific peers. But when my advisor asks me what it is that I've achieved this year, I say I ran a model of the ocean and the atmosphere. I say I ran a model of the ocean and the atmosphere. I say I ran a model of the ocean and the atmosphere. I say I ran a model of the ocean and the atmosphere. Models of the ocean are a useful tool to educate. With observations, theory, ocean sciences are really great. In short, what am I saying here? It's not at all a bad career to run a modern model of the ocean and the atmosphere. In short, what am I saying here? It's not at all a bad career to run a modern model of the ocean and the atmosphere.
And I get out of breath just walking up the stairs. Whew, that was fantastic, Paige. Thank you very much. Now to a not much more serious note, but in a way, sort of. Our final speaker of the week is a person who has contributed greatly to the ocean sciences since earning his PhD at Scripps in 1980. During his tenure at the University of Washington and as a senior scientist at NOAA's Pacific Marine Environmental Lab, he participated in and then led the effort to establish the El Nino and climate monitoring efforts around the Earth's equator, which are now known as the Global Tropical Moored Buoy Array, which of course are composed of tau, Then Parada was established in the Atlantic Ocean, and finally Rama in the Indian Ocean. He works with the global community, with the World Meteorological Organization, with CLIVAR, with JCOM, and he works on these and other great scientific efforts. His work has been cited more than 24,000 times in the literature. Think about that a minute. That's incredible. He's also a past president of the American Geophysical Union, and he currently chairs the ethics board there. During this past week, Mike has been observing the scientists and events that have occurred during this Ocean Sciences meeting, and at this time, we've asked him to provide his observations and provide us an outlook for the future. So please welcome Dr. Michael McPhaden.
You hear me? Yes, you can. Okay. Thank you, Dick, for that very gracious introduction. And thanks to the program committee for the invitation to speak today. And especially thanks to you all for showing up at the bitter end of this week-long whirlwind of excitement in ocean sciences. So I'm going to talk about a little bit different. I'm not going to attempt a summary of this meeting. It's too overwhelming. But I did go on a information gathering hunt this week, and what I'm going to talk about is ocean sciences in the era of the Ocean Sciences meeting. Excuse me, and I also have to apologize for the hoarseness of my voice. In addition to picking up many great ideas at this meeting, I also picked up a little bit of a cold. So, but before I get into this, I first want to acknowledge the Ocean Sciences Program Committee, because I know they've worked very long and hard over many, many months, years perhaps, in putting together this great event. And are there any members of the Program Committee in the audience? Would you stand, please? Yes, would you give them a great round of applause? Yeah. I mean, we have had the full spectrum of ocean science, research, ocean engineering and technology, ocean policy, education and outreach. It's really been a wonderful menu of events this week that we could take part in. I would also like to give a shout out for the Safe OSM initiative that ASLO, TOS, and AGU initiated this year. You've probably seen some of the people wearing these green buttons. We're specially trained to help anyone who was either experiencing or witnessing any unwelcome or unwanted behaviors from their colleagues here. And we know that, in particular, sexual harassment has been a longstanding and pervasive problem in our community, one that's been tolerated too long. It is harmful to those who experience it, and it's harmful to the community in general. So Safe OSM and many other programs that we are launching in AGU with other partner societies is our commitment to you to say that what was once acceptable will no longer be tolerated. So with that, then, let me get into the subject matter. Here's a brief history of the Ocean Sciences meeting. So the first meeting was held in 1982 in San Antonio, Texas. There were about 500 attendees, and it was a partnership between AGU, which had primarily a focus on physical oceanography, submarine chemistry, and biology, and ASLO, which had very much of a biological focus, but also salt and freshwater environments. The meeting was actually wildly successful, and it was carried on successfully for many years, until the big kerfuffle. AGU and ASLO had a falling out around 2002, 2004 time period. They parted ways, and they held separate meetings. And this all blew up when I was the president of AGU Ocean Sciences. And so for 2 years, it was my #1 priority to get these organizations back together to hold a single meeting for our community. And with a lot of effort and a lot of help from our friends, we succeeded in that. And as a bonus, when we held our joint meeting in 2006, it was with the Oceanography Society. So now we had a partnership between three organizations. And this meeting, Portland, we have 5,384 attendees. That is about the same as the last time that we met in 2016. And 426 sessions. That's almost as many sessions as there were attendees at the first meeting. 30% of them are students, the next generation. And 30% of them are international. The meeting this year is larger than the fall meeting was in 1990. And, we have to be careful because you know what they say about the fall AGU? It's so big that nobody goes anymore. So ocean sciences, the face of ocean sciences has changed dramatically since this first meeting in 1982, as has the face of some ocean scientists. Let me give you an example. Here are 7 ocean scientists in the early 1980s at a meeting in India. You may recognize some of these people. There's John Morrison, Dennis Moore, Jay McCreary, Mark Luther, and Raina Fine in front. I'm on the far side there, and next to me is Dennis Moore, a friend and a colleague and a mentor to me at that time. Well, here we are at the Portland Ocean Sciences meeting in 2018. And the wonderful thing about a meeting like this is you get to present your latest research, get feedback on it, learn some new things, but also make new friends and reestablish some old relationships. And so that's one of the wonderful things about being an oceanographer, the community that you run with throughout your career. Now, there have been tremendous advances in ocean sciences since 1982 across all fronts. But in addition to that, there are some topics that we could not have discussed at the 1982 meeting. And through the week, I've tried to make a list of fields, as far as I know, that did not exist in 1982. And you could look at that list and we can argue about whether it's complete, whether there are things on that list that should not be there, whether there are other things on that list that should be there. But the real point is that all of us could make a list like this. And that's a measure of how profoundly transformed our field has been by these new ideas. Climate change. Climate change is the defining environmental problem of our age. And to understand climate change, you must understand the ocean. In 1982, the atmosphere had 340 parts per million carbon dioxide concentration. Today, it's over 400. The IPCC did not exist in 1982, but we did have the Charney Report, which was published in 1979. And as a measure of how little we knew about the ocean's role in climate change, I just pull one quote out of this, which is, "Simple model calculations involving Ekman pumping suggest that the effective thermal capacity of the ocean for absorbing heat could delay the attainment of global thermal equilibrium by orders of a few decades." I underlined simple model calculations involving Ekman pumping. I mean, this is a very primitive level of understanding. But today, of course, because of detailed analysis of historical records and the advent of the Global Ocean Observing System, we now can quantify how much heat is going into the ocean. And it's over 90% of the excess heat from anthropogenic greenhouse gas forcing. And yes, it is delaying equilibrium, and so you will oftentimes hear about the heating that's in the pipeline or our climate commitment. And that's because of this slow adjustment of the ocean to the anthropogenic forcing. And so even if we stopped emitting greenhouse gases today, we're in for at least another ½ degree Celsius of warming on the planet. So not only have our ideas been transformed, but so have our technologies. In the early 1990s, we were really tethered primarily to research vessels. And today, of course, research vessels are very important to us. I mean, we can't do our work without them. But in addition, we have this spectacular array of autonomous vehicles that we can deploy all over the world to address the cutting-edge scientific problems that we are today. And not only do we have these platforms, but we have an amazing array of modern sensors as well for physical oceanography, marine biogeochemistry, and other related fields. And of course, all of this data, much of this data can come to us in real time through satellite telemetry. 1982 was also the beginning of the satellite era for oceanography. And in 1982, there was only one satellite flying that had a sensor that would be of any value to oceanography, and that was AVHRR on the NOAA Polar Orbiter for sea surface temperature. We were on a steep learning curve as to how to figure out how to utilize these data. And one example of that was the algorithm had not been yet tuned to account for stratospheric aerosols. And so, as it turns out, El Chichón erupted in March and April of 1982, throwing a cloud of aerosols into the stratosphere, which effectively blinded the satellite to the record high sea surface temperatures in the equatorial Pacific associated with the El Nino of the century, and it delayed detection of that El Nino for several months. Well, now, of course, we do much better. We have many, many satellites flying in space for oceanographic measurements of sea surface temperature, surface height, salinity, gravity, color, and others. And we also have the incredible instantaneous pinpoint accuracy of the Global Positioning System, something that did not exist in 1982. Computers. Here's the fastest computer in the world in the early 1980s. It's the Cray XMP. This was at NCAR. And today, my cell phone has more computing power than that huge machine. Now, today's supercomputers are really super by today's standards. And with these computers, we can make really remarkable simulations of the ocean and the climate system with a high degree of realism. And this is one model, the GFDL coupled model version 2.6. What's shown there is the sea surface salinity in the North Atlantic through the Arctic. And let me see if I can play this. This is a 1/10 of a degree resolution in the ocean. You can see the high salinity in the North Atlantic, the very fresh water in the Arctic, and you can see the eddies in the North Atlantic current as it moves westward. You know, this is more fun than the lava lamps I used to watch when I was. But this is what we can do today. The digital revolution. Internet, personal computers, mobile devices, and social media have transformed the way in which we access and process information and how we interact with one another. PowerPoint. You know, the quality of presentations at this meeting was generally pretty high. And some of you in the audience, I'm sure, remember the days when we would make our presentations with acetate overheads and scribble something with colored pens. And if you really wanted to improve your technique, you could do a tutorial with Lenny Laskowski. But even our presentation tools have greatly advanced from those early days. So that's looking back 36 years. What about looking forward 36 years? I mean, what is ocean sciences going to look like in 2054? Well, to paraphrase that great philosopher and baseball player Yogi Berra, prediction is hard, especially when it's about the future. Now, you know, we can't reliably forecast what oceanography or ocean science is going to look like in 2054. But we can, I think, say with a high degree of confidence that we will look back then at this era with the same awe and amazement that we look now back at 1982. It will be astounding, the changes that will have taken place. And more specifically, though, there are some trends that we can point to that I think are going to carry us forward. One is that big things are going to get smaller and smarter, you know, like these little CubeSats. Big data is going to get bigger and bigger. Computer power will continue to increase according to Moore's law. We'll see increasing use of robotics for data collection and remote ocean environments. Because of the massive data that we'll be collecting from satellites and models, we'll have to rely more and more on artificial intelligence and machine learning to access, process, and interpret that information. Oceanography has always been about exploration and discovery, and that will also be true in the future. Now, what form that exploration takes and what discoveries will be made, we can't say with any certainty, but we can be sure that as we try to understand the intricacies of the ocean system and how it connects with other parts of the Earth system, the journey will be filled with adventure and many surprises. And I will make a prediction here that is, as we address problems of increasing complexity and increasing challenge, that our science will become more interdisciplinary, collaborative, and international in flavor, even more so than today. There will be challenges. I mean, it's not going to be easy, and many of these challenges will be more than just scientific and technical. Well, funding. I don't think in my entire career I've ever seen a period where funding wasn't of concern to me and other of my colleagues, and I think it's going to be even more so. The traditional sources of federal funding for research in the U.S., there's been downward pressure on those now for many years, and that downward pressure is increasing. So in some sense, I think we need to rethink our business model a little bit for how we fund oceanographic research. Think of more sources like foundations, the private sector, and also leverage our investments through partnerships with the international community. There'll also be none of these are really new, but the competition for ship time and access to facilities, communication. I mean, how do we effectively communicate the importance of ocean sciences to broad communities? With the diversification of media, there are many channels now, the internet and cable networks, where people can get their information. And there are a lot of false prophets out there. So it's a real challenge to make sure that our message gets heard behind a very large background noise. It's kind of a signal-to-noise problem in the human dimension space. Time. How do we find the time to do all the things we need to do, all the things we want to do, and still have a life? That's the problem today. It's going to continue. And then finally, there will be political headwinds. And that's because, there are many areas of ocean research that are controversial because they threaten the status quo of entrenched interests. And so we are dealing with those kinds of situations now, and we will have to deal with them in the future. So is it worth it all? Of course it is. In this era of fake news and alternative facts, there will always be a need for ocean information that is credible, authoritative, and relevant. And these are just a few examples, of course. Research can inform many policies and decisions at the interface of ocean science and societal need. Climate variability and change, we've already mentioned. Natural hazards, risk reduction, ecosystems and fisheries management, and a whole host of other activities. The UN Sustainable Development Goals are shown there. Two of them are related directly to the ocean. One is climate action. The other one is life in the sea. Many of them are indirectly related to the ocean. No hunger. Well, many people around the world depend on protein from the sea as part of their diet. Poverty. People living in poverty are more vulnerable to natural hazards. For example, sea level rise, severe tropical storms, and tsunamis. And so, and I'm sure that many of you can think of your own examples. Oops, sorry about that. Many of you can think of your own examples of how the kinds of things, research that we do in ocean science can make the planet a better place to live. But I want to give you just one that I think is timely and relevant, and that is the 2015 Paris Climate Agreement. And this was adopted by 195 nations around the world. It is based on the premise that climate change is real, humans are causing it, it's a threat, and we can do something about it. And the details are that to limit the warming of the planet by no more than 2 degrees Celsius by the end of the 21st century with an aspirational goal of 1.5 degrees Celsius. And we can argue about the sensibility of those limits, but one thing is absolutely clear, that scientific evidence formed the foundation of this agreement. It's the kind of information that the climate community and the ocean community have provided through research over several decades that form the foundation of this agreement. And now, there are some national leaders who have turned a deaf ear to this evidence, and they have been enticed by the background chatter of climate change denial, but we can still take strength and inspiration from the fact that for most of the world, science matters and our voice is heard. So let me conclude with this quote. The sea has always challenged the minds and imagination of men and women, and even today it remains the last great frontier on Earth. It is a realm so vast that with all our efforts, we have explored only a small fraction of it. Does anyone know who wrote that? You got it. Rachel Carson, 1951, The Sea Around Us. And, you know, for all that we have learned in the past 36 years, for all that we have learned in the past 67 years, this quote holds as true today as it did back then. For all the progress we've made, there is still so much more to do, so much more to learn, and so much more to discover. So with that, I'd like to end. Thank you. Safe travels back, and I'll see you in San Diego in 2020.
Want to take a question? Want to take a couple? Would you like to take a couple of questions? Sure. We could take a couple of questions if anybody has any. There are microphones up toward the front, to my right, in the center, and over on the left-hand side. A couple of brave souls. Center.
First. So that slide that you had all the steps, what were they? I was trying to read them. The third 2 slides back, you had a whole bunch of stamps, no poverty.
Oh, yes.
Yeah, what are those?
Those are the UN Sustainable Development Goals. They were developed by the UN over several years, and they're aspirational. You know, how do we improve the lives and the environment for the planet, basically?
Okay, someone else in the center, please.
I would agree with you, you know, that this is an achievement with the Paris Agreement. But in this country, I feel sometimes, you know, have we failed as a community to communicate the message, particularly, you know, if you see current administration that seems to be, you know, in a whole range of the population, reflecting that the views of a whole range of population. So what do you think? Have we failed, and what can we do better to reach that? You know, those parts of the population?
Well, I mean, that is the great challenge, and you know, clearly somehow we have failed in the U.S. That's pretty evident, and you know, how we rectify that situation. First thing I would say is, if you live in the U.S., vote. This is a way to make your voice heard too. But I don't have simple answers for that question. But you really asked a very fundamental question.
Question?
Yep.
Yes, so SDG 13, climate action. We had a town hall meeting this week on moving from observation to action scientifically, or at least evaluating what the world's climate choices might be. And I was wondering if you might have any comments on the role of science and oceanography in, you know, in being responsible citizens when it comes to climate action.
Well, you know, at a very personal level, we all have to look at our carbon footprint. And I think one of the, you know, as we think to the future, you know, less air travel is something that we can all do. Although, you know, face-to-face meetings are very important. But as bandwidth increases and technology increases, we may be able to do a lot more of our business remotely through video teleconferencing and things like that. Personal choices you make are very important as well. So there's lots of things you can do on a personal level. But it really does require coordinated political action to really address the problem. And I think this, climate accord is a step in the right direction. But all nations need to be on board, especially our nation.
Final question from my right, please.
Mike, I'm curious to get your opinion on changing business models. You sort of referred to the fact that the traditional pillars of support in the U.S. from the federal agencies has changed, and that private foundations might be able to step in. I wasn't thinking so much as the source of the funding as much as how we actually go about doing the scientific enterprise in ocean sciences, and if you had any thoughts on that.
So what was the question then? I got the...
I was curious to know if you have any thoughts on what a different way of how we go about conducting our business might be, a different business model. In other words, something that might be different from what we do now, which is write a proposal, 8% gets funded, so on and so forth.
Yeah, I think you always have to compete your ideas. So I think putting them down and having them vetted, I think, is very important. I think it's a problem with the sources of funding that we have traditionally relied on are decreasing. And I'm of a generation that benefited from Sputnik. The United States was throwing tons of money at STEM fields. And that's changed now, though, and there are more and more pressures to spend those kinds of funds in other ways. And this has been a trend that's been going on really for decades, but we're experiencing the impacts of that even more today as our community grows and the dollars don't grow at the same rate. So we need to be clever, and we need to be proactive in thinking about alternative modes of funding, and they're out there, and we can see opportunities with private foundations and the private sector. And again, I think international partnerships are very important because there's a lot of resource in other countries being devoted to ocean science. And we need to think about how we can work effectively with other countries and other institutions that have common goals and want to share resources and do something that is grander than any one country could contribute. The Global Ocean Observing System is an example like that, but there are many others too.
Thank you, Mike.
Yeah. Okay. Thank you, Dick.
Thank you, sir.
Well, we're almost at the end of our Ocean Sciences Meeting 2018. I have a couple of remarks to make, and then we'll turn you loose. This week, we've heard policy speakers from the United States and from Europe talk about how they do business in each of these countries and what the future looks like. We have heard, in Kay Beidle's word, scientific superstars who are leading us beyond today's understandings of the ocean to the future. We've honored award winners, and we hope we've inspired the next generation of ocean scientists. As Fred mentioned Sunday at our policy plenary, these meetings do not just happen, and we would like to take just a moment to thank those individuals once again. Mike has already mentioned the planning committee of subject matter experts, so I'll just thank them one more time. They work tirelessly to select the appropriate sessions and then organize all the posters and oral sessions that you've attended this week. We want to thank our sponsors and our exhibitors who brought their new technology to the fore, and without those people, these meetings don't happen. So if you see them around, please thank them. From the AGU staff, Fred, Kay, and I, again, would like to thank Nicole Oliphant, Judy Dolly, and most of all, Heather Nally, who was really the backbone of this meeting. She really did most of the heavy lifting. ASLO's Helen Snyder-LeMay and Jenny Ramarui from the Oceanography Society were there every step of the way to make sure that we didn't trip over anything. Your student chairs, who did a fantastic job organizing all of the early week student and early career activities, really deserve a huge amount of thanks because It makes you feel good, but the fact that they came in, I think they outworked the rest of the committee combined. They were fabulous, and they were Camille Panilio from over here. We also had Haley Scheibel from ASLO. I'm not sure she's here or not. And then Miriam Gleber of AGU. I know Miriam's out skiing, and hopefully she doesn't have the same issue that you did, Camille. Anyway, they were fantastic, and this meeting would not nearly have been the same without them. At this point, I'll ask the co-chairs, Fred Bingham from AGU and Kay Beidel, to come up on stage. And I'd like for them to just stand over here. And I'm going to introduce you to the co-chairs for 2020, which is going to be held in San Diego. As I call them, please come forward. From the Oceanography Society is Kristen Buck. From ASLO, it's Alessandro Caversi. And from AGU, Margie Friedrichs. All right, so these are your co-chairs for your next Ocean Sciences meeting in San Diego in 2020. Give them your support. There are surveys to be filled out, so if there are things that you didn't like about the meeting, you can talk to us three. If there are things that you can suggest for the next meeting, you talk to those three, okay? Anyway, thank you all very much for attending, and on to San Diego.
Awesome job, dude. Good stuff.
Good.